So 7.3b will be introducing you guys to two new sets of identities called the product to sum and sum to product. The lesson goal is the same as it has always been. We're going to evaluate, simplify, and actually prove, verify expressions. Now, these sums to product and product to sum identities apply when you are adding and subtracting trig expressions. So again, I'm not going to go over where these guys came from. If you are interested, I can show you in class. But to suffice it to say, just like with the other identities, the product to sum identities come from the sums and difference identities. So if you notice how what's going on here, I have a sign of a sum plus sign of a difference. If you were to actually take those two identities, stack them together, and then add the two equations, this is exactly what you would get. So it's not really a mystery. It's not a secret where these guys come from. But I'm not gonna spend time talking about it. I'm not gonna quiz you or test you over it. You just have to be able to use it. But I can show it to you in class if you're interested. So here's the product to sum identities. These are the rules that you have to follow if you're ever multiplying different trig functions. Namely, if we do sine times cosine, this is the pattern you follow. If you do cosine times cosine and they're different angles, right? If the angles were the same, you just write it as a square. But if you're doing cosine times cosine of different angles, this is the pattern you'd follow. And similarly, sine times sine with different angles, this is the pattern that you would follow. What the sum to product does is it goes incomplete. It goes to the other operations. What if I added two sine values that were different angles? This is the pattern you'd use if you subtracted two different sines, if you added two different cosines, if you subtracted two different cosines, right? We're not going to bother with tangents and secants, so on and so forth. Just like what I said at the beginning of this unit, there really is not a lot of teaching involved. I will give you the identities. I will give you these patterns. You just have to be able to use it. And what I will ask you to do in terms of using it is just basically recognition of patterns. Can you recognize a situation where you might need sums to products or products to sums or any of the ones we talked about in the past? You need to recognize when to use double angles, when to use sums and differences, so on and so forth. So for example, I'm just choosing random, weird, easy peasy examples from the practice. If I ask you to express sine of 3x times sine of 5x as a sum of trig functions, I can't wave the red flag any further. I'm telling you to write it as a sum, express as a sum. And what do I give you? I give you two signs multiplying. So clearly, this has to be a product to sum formula. Specifically, this is sine times sine. So I just go to my product to sum. Sine times sine is this pattern here. So I'm not going to do anything special. I'm literally just going to follow this pattern here. So there really is not a lot of work done. It's just, you just have to be able to follow instructions. So sine of 3x times sine of 5x equals, according to the pattern, 1/2 times the quantity cosine of, subtract the angles, 3x minus 5x, minus cosine of, add the angles, 3x plus 5x. And then you just simplify. That's cosine of negative 2x minus cosine of 8x. And we should know the even-odd identities that if there's a negative inside of a cosine, nothing really happens. You can just basically ignore the negative because cosine of a negative angle is the same as cosine of a positive angle. That's it. So I didn't really do a lot of thinking. This was basically automatic. I just followed the product to sum identity. And we should be able to go backwards, right? If I ask you to do product to sum, let's do sum to product. So for example, let's say I asked you to write sine of 7x plus sine of 3x as a product. Again, I'm giving you a whole bunch of red flags. I'm telling you, write it as a product. And I start off with a plus. So this is clearly sums to product. So I'm not going to scroll back up. You should have it in your notes. But I'm just going to follow sine of alpha plus sine of beta, sine of x plus sine of y, whatever variables you use. I'm just going to follow the pattern that we get when we add two sines. So according to the pattern, that's 2 sine, and then you add the angles, divide by 2, times cosine, you subtract the angles, and divide by 2. Again, I'm not making this up. I'm just following the pattern that I have in front of me, and then you just simplify. 2 sine of 10x over 2, cosine of 4x over 2, that's 2 sine of 5x, cosine of 2x, right? So, easy peasy. So this is a very short lesson because it is just recognizing the patterns. I'll give you the patterns. You just need to use it. Let's just do one random proof problem just to show you, again, the logic doesn't change. All those hints that I gave you, start on the more complicated side. See trig function being squared, think of Pythagorean identities. Now I'm going to add, if you recognize these patterns, if you see different sines being added, if you see different cosines being added, or if you see different sines being multiplied or different cosines being multiplied, you have these identities. So suppose I ask you to verify that sine of 3x minus sine of x over cosine of 3x plus cosine of x is equal to tangent of x. I don't think anyone's going to argue that the left-hand side is more complicated, so that's what we're going to start with. Now notice what we have here. We have sine, oops, that's not a highlighter, sine of a particular angle, 3x, minus sine of a different angle, x, over cosine of an angle plus cosine of another angle. So if you look at the numerator and denominator separately, in the numerator we have what? Sine minus sine. In the denominator we have cosine plus cosine. Hey, we do have formulas for those, right? Here is sine, here is sine minus sine. We can follow this pattern. And here is cosine plus cosine. We can follow that pattern. So I'm just going to, on a whim, maybe I'm right, maybe I'm wrong. I'm on a whim, I'm going to follow those patterns. Nothing crazy, nothing, complicated. I'm literally just following the pattern. So following the sine minus sine pattern, I get 2 cosine of, you add the angles, divide by 2, times sine, you subtract the angles, divide by 2. And then in the denominator, I'm going to follow the cosine plus cosine pattern. That goes to cosine, you add the angles, divided by 2, times cosine, you subtract the angles, divided by 2. So then that gives me 2 cosine of 3x plus x is 4x over 2 is 2x. Sine of x over 2 cosine of 2x, cosine of x. Hopefully we can see that the 2 cosines of 2x cancels. I don't need to do the double angle formula there. So you get sine of x over cosine of x, which equals tangent of x, which is exactly what we wanted. Right. So again, this lesson, in terms of the instruction, is very, very short. It is this thing that we've been working on all week. It's just I'm adding more tools to your toolbox. I'm adding more identities for you to use. So the only way you can get better at this is if you practice. Good luck.